Neuralink, a company founded in 2016 by Elon Musk and a team of engineers, is developing a brain chip interface that can be implanted inside the skull. The company claims that this interface would ultimately enable disabled people to walk and talk again and will also help to recover vision, and of recently is the target of a federal investigations over its animal trial program. How about we find out all about Neuralink and its progress thus far? Okay? But before we begin, we'd like to welcome you to the channel and also remind you that if you enjoy this type of content, please like, subscribe, and share the video. With that said, let's get started. After the startup missed prior deadlines he had set, Elon Musk said on Wednesday, the 30th of November, that he anticipates a wireless brain chip developed by his company Neuralink to start human clinical testing in 6 months. The startup is working on brain chip interfaces that, according to its claim, might allow crippled people to move and communicate once again. Musk added on Wednesday that the company will also focus on repairing vision. Neuralink, a company with offices in the San Francisco Bay Area and Austin, Texas, has recently been testing its products on animals while waiting for the U.S. Food and Drug Administrations to give the go-ahead for human clinical trials. But hey, before we get into the juicy details, what is Neuralink all about? Neuralink, a company Elon Musk helped from intending to directly connect our brains to computers, demonstrated how far it has come from its monkey mind-pong moment in 2021. The latest iterations of the company's implantable brain chip may let the blind see or restore movement to individuals with spinal cord injuries. Musk and a few researchers said in a thorough update on November 30th. Musk's company is developing a method to implant thousands of electrodes onto the surface of people's brains that are thousands of times thinner than a strand of human hair. Each electrode consists of a tiny wire that is attached to a quarter-sized chip package that is battery-powered and wirelessly recharged and inserted into the space where a circle of the skull is originally stood. The N1 chip uses wireless technology to connect to the outside world. How feasible is Neuralink? Although Musk's ultimate goal of using Neuralink to socialize with super-intelligent AIs is still years off, the innovation is still far from its first medical applications. But the firm said at a show-and-tell meeting that lasted more than 2 hours that it is making substantial progress, including applying with the Food and Drug Administrations to initiate human trials that it intends to start within 6 months. According to Dan Adams, a researcher at Neuralink who is involved in a project to repackage camera data into brain-compatible format and send it straight to the visual cortex, our goal will be to turn the lights on for someone who has spent decades living in the dark. You see, Musk has some credibility when it comes to cutting-edge technology. His reusable rocket firm SpaceX and electric vehicle startup Tesla are fundamentally altering the automotive industry and SpaceX's, respectively. However, the turbulence that followed his $44 billion acquisitions of Twitter has hurt his reputation as a cyber genius. Furthermore, Musk's Boring Company, which uses tunnels to redefine automobile transportation, hasn't yet delivered on its claims. It doesn't appear that Neuralink is any simpler than social networking. There are a lot of technological, legal, and ethical problems involved in connecting computer hardware to our wetware. It is one thing to help the blind see, but those of us who already spend too much time on our phones might not benefit from a digital feed directly into our brains. Let's now take a look at what Neuralink has been working tirelessly toward. Neuralink technology to aid quadriplegics in walking. Neuralink previously demonstrated how its electrodes can monitor brain activity. Neuralink computers developed their ability to decipher motor control signals by studying the brain activity of a monkey named Pager while it played the vintage video game Pong. Later, only the monkey's brain inputs were needed to operate the game. Sake, the test monkey, used its intellect to follow instructions and type on a virtual keyboard at Neuralink's show-and-tell gathering, which was held to attract new expertise. Monkeys are persuaded to sit beneath a charger incorporated in a branch directly above their heads in exchange for a fruit smoothie for the implants to wirelessly charge. But the most significant discoveries on Wednesday send signals back to the neurons that make up the brain and nervous system using the same electrodes. A pig's spinal cord was utilized in one experiment to regulate various leg motions. This technology may one day assist patients with quadriplegia walking or using their hands. Neuralink's method entails hearing sensory signals from the leg and replaying them back to the brain so that the brain is aware of what is happening in addition to diverting the brain's movement commands to the legs. Neuralink has made headway towards its objective of utilizing its N1 chip to collect brain signals and then route them around spinal cord damage to enable paraplegic patients to regain their ability to walk. Joy O'Doherty, a researcher working on Neuralink's motor control technology, said that although there is still a lot of work to be done to realize this whole vision, it is clear that the necessary components are in place. Next, we have seeing images and typing with your mind. In a different experiment, visual information from a camera was transmitted into a monkey's visual brain, where the monkey recognized virtual flashes as representing distinct locations. That is the technique Neuralink is hoping to help create a visual prosthesis for blind individuals. Neuralink demonstrated next-generation models with more than 16,000 electrodes in contrast to the original generation's 1,024 electrodes. According to Adams, adding that much information would significantly increase the image's fidelity for visually impaired people. According to Adams, a blind people would have 32,000 points of light to create an image. If a gadget were placed on both sides of their visual cortex, people with paralysis can use their implants to type with their minds thanks to another Neuralink application. In contrast to someone with working hands, Musk asserted, "We are convinced that someone who has no other interface to the outside world would be able to manage their phone better." Neuralink and its counterparts, what sets it apart? In its quest for brain-computer or brain-machine interface technology, Neuralink is not fighting alone. Numerous studies have been published by academic researchers, and several firms like BlackRock Neurotech, Precision Neuroscience, Synchron Medical, and Paradromics are also involved. Some people like Neuro use non-invasive techniques that don't involve surgery. In April, Synchron started testing a device on humans with 6 patients to treat paralysis. BlackRock has finished a few and is recruiting for others, such as an investigation into whether a computer interface can facilitate speech. Before Neuralink was created, another initiative to digitally connect the extremities to the brain started in 2013. Neuralink's focus on mass production sets it apart from some of those initiatives. Production is hard. I'd estimate 100 to 1,000 times tougher to get from a prototype to a device that is safe, dependable, operates in a variety of conditions, is affordable, and is done at a scale. Musk remarked, "It's quite challenging." Musk said he expects to own one of Neuralink's brain chips and that the company plans to produce millions of them. The company is attempting to automate as much technology as it can to achieve that goal. More advanced machine is planned to undertake more of the surgery, including cutting through the skull. Its R1 robot weaves electrodes into the brain without harming blood arteries. Neuralink is also attempting to position its brain chips on the exterior of the dura, a layer that is one layer external to the brain. This calls for significant modifications to the robot's needles and needle steering systems, which the company is now developing. According to Christine Odabashian, who is in charge of Neuralink's surgery engineering team, there are only around 10 neurosurgeons for every million individuals. We need to figure out how one neurosurgeon could oversee several treatments at once to do the most good and have a cheap and accessible technique. Musk's futuristic vision is another significant distinction between Neuralink and its competitors. The company has lofty goals. Musk described the device as a universal input-output interface that could interface with every component of your brain. But the long-term scheme is significantly more elaborate. So, tell us what you feel about Elon Musk's Neuralink's upgraded brain chip. Do you think it is one for the future? And also, what do you feel about the installation process of Neuralink? Let us have your thoughts down in the comment section below, and also be sure to leave a like and subscribe to the channel. Thank you.